In this video, we're going to look at another example of a quadratic number pattern, and this one is so nice because it's got a trick that catches a lot of people out. And so you work out the difference between these two, and it's 51, but it's negative 51. And the difference between these two is negative 45. And having an awareness of when it's negative and positive is crucial because it completely changes all the answers that follow. And so to get from minus 51 to minus 45 is actually going up by 6. And so you've got a pattern where it looks all happy and positive, but actually it's going down. And in a second difference level, it's actually going up. And so the next term, to work out the next term, we just continue this pattern, and it's going down by 33. So 33 less than 109 would just be 76. Determine the formula. And so what we're going to do is we're going to start on the bottom layer and make the bottom layer. I'm just going to write those numbers here. So the bottom layer on the left equals 2a. The formula to get to the next layer is 3a plus b. And the formula to get to the top layer is a plus b plus c. I start at the bottom first, and so 2a equals 6, therefore a will be 3. Then I go up a layer, 3a plus b equals minus 51, and so b would equal minus 60. Go to the top layer, a plus b plus c must get me back to the first number. Therefore, c equals 301. And so my formula in its most general state would be an squared plus bn plus c. And now that I know that a is 3, b is minus 60, and c is 301. And so that's the general term, the formula, the nth term, and we're going to use that to work out the rest of the questions. Which term in the pattern will have a value of 508? So that's not subbing in for n. It's not saying what is the 508th term. It's which term. So whenever you have which term, you sub that in for tn. And so let's do it here. So 508 will equal the formula. And then from there, it's just bringing everything to one side. I like to keep it where the n squared is positive. So let's keep it that side. And we end up with 3n squared minus 60n minus 207. Then if you can factorize that, that's incredible. You can use your quadratic formula from here. You could try and divide by 3, and if you do that, you actually find that it ends up being quite a nice answer. And that you can then factorize will be n minus 23 or n plus 3. That means the answer is n is negative 3 or n is 23. But you can't get a negative number of terms, so it must be 23. So which term is 508? It's the 23rd term. Then this is a great question. Between which two consecutive terms of the quadratic pattern will the first difference be this? And so what jumps out for me is that they're talking about the first difference. And so I'm going to live this question on the first difference layer. And the first difference layer, if I wrote it out, was this. And so I'm going to start by doing my linear or arithmetic formula. First term is minus 51. The difference each time it goes up by 6, like we discovered earlier. And that will leave you with a formula of 6n minus 57. And you're saying which term would be 453. That gives you an answer of 510, and if you divide that, you get 85. So the first difference level would be 85. So between which two terms would it be? Of the quadratic, it will be between term 85 and 86, because 85 and 86 would then give you, on your first difference level, term 85. So that's a helpful way to remember. If I'm on the first difference level, the one on the left will be the same number. The one on the right will always be one bigger. Last question, show that all the terms in the quadratic are positive. And so if I think of this formula as if it's a graph, very, very roughly speaking, you've got a graph that is happy, and you've got a graph that then, because it's happy, it will have a minimum value. And so if I can work out this turning point, then I can hopefully show that all the terms in the quadratic are positive. And so this graph is rough, so it might be that the graph is actually above there, but let's see. So I'm going to head the turning point way. So the turning point is minus b over 2a. That gives me an answer of 60 over 6, which is 10. So my n value, or my turning point value, would be at 10, and then we're hoping that it will be above here, but let's try that. So I'm going to sub 10 into all the n's in the formula, and when I do that, I get an answer of 1. And so my turning point is at 10 and 1. And so my graph would look like this. What does that mean? If it's a happy graph, because a is bigger than naught, so since a is bigger than naught, it's a happy graph, but my turning point is 10, 1. My turning point has a y value of 1, which means it's above here. That means that none of the terms are going below here. That means that none of the terms are negative, which means that all the terms in the pattern are positive. And so that's how you can do these questions. It will change your life if you think of them patterns as if they're graphs. I hope that you found this chunky video useful. If you did, please like it, subscribe to our channel, and share it with your friends. Thanks.